Welcome to the Oxygen Alliance YouTube channel, where we bring you videos on installation, maintenance, and various trainings on oxygen equipment and devices. If you have comments and or questions, drop them in the comment section below or write to us info@oxygenalliance.org. Remember to like our videos, subscribe to our channel, and hit the notification bell.
Hello everyone, Happy New Year from the Oxygen Alliance. Welcome to today's talk brought to you by Oxygen Alliance. My name is Sharon Ngozo. I'm a biomedical engineer for Oxygen Alliance, and I'm hosting the call from Lilongwe, Malawi. For those just joining us for the first time, the Oxygen Talk is a virtual meeting where we discuss various topics related to medical oxygen. So I'd like to know where you're joining us from, so you can paste your name in the chat and your location. If you want us to add you to our emailing list where you can get notifications of the upcoming events, please do share with us your email in the chat. So today our OpenO2 engineers will present on a topic of neonatal oxygen equipment. So they will guide us through the equipment used in the neonatal department and share with us the care and maintenance of these equipment. So I encourage you to take some notes, as we'll be looking forward to be hearing your comments and your questions at the end of the presentation. So without wasting much of your time, let me hand over the floor to Jen Chaponda, who will introduce the whole team. Over to you, Jen.
Thank you so much, Sharon. Indeed, my name is Jen Chaponda. I'm a biomedical engineer at the Global Health Informatics Institute and at the OpenO2 initiative. With me are my colleagues, Aubrey, Chinkunda, and Chimwemwe, who are also biomedical engineers and at the OpenO2 initiative. And today we are privileged to have a guest from NEST, Vitumbiko Msowoya, and together we'll be presenting on the topic neonatal oxygen-related equipment. So this is the outline for the presentation. Firstly, we're going to look at an introduction to neonatal oxygen-related equipment. Then we'll look at the delicate nature of neonates. And then we'll look at oxygen equipment used in the neonates. And lastly, we'll look at the care and maintenance of this neonatal oxygen-related equipment. To begin with, let's define some key terms that form the foundation of this presentation. So the first word is neonate. Who is a neonate? A neonate is an infant between 0 and 28 days of life. And the other term is oxygen-related equipment. And these are tools and devices that are designed in order to produce, to regulate, and also to administer oxygen for medical purposes. Another term that we should define is oxygen toxicity. So this is a condition that results from the harmful effect of breathing in high concentration of oxygen for a prolonged period of time. The last word is oxygen blending. So this refers to the controlled combination of oxygen with other gases in order to achieve a specified concentration. So oxygen is blended in neonatal therapy in order to avoid oxygen toxicity. And these two pictures are just showing some of the examples of neonatal oxygen-related equipment that have been connected to neonates. Moving on, let's look at the statistics of neonatal mortality. So this is a world map showing neonatal mortality rates across regions in the year 2021. And neonatal mortality rate is the probability of dying during the first 28 days of life, expressed per 1,000 live births. So according to the World Health Organization, the first month of life is the most vulnerable for child survival because most children face the highest risk of dying in their first month of life. From the map, you can see that there are clear differences in neonatal mortality across regions and countries. For example, regions like Europe, North America, Australia, and New Zealand had the lowest neonatal mortality of less than or equal to 5 deaths per 1,000 live births, whereas regions in the Sub-Saharan Africa and Southern Asia had the highest neonatal mortality rate of about 25 to 35 and greater than 35 deaths per 1,000 live births. So one of the contributing factors to an increased neonatal mortality rate in low-resource countries and regions is having inadequate basic technologies, including neonatal oxygen-related equipment. Moving on, let's look at the delicate nature of neonates. Neonates, especially those that are born prematurely or those that have a low birth weight, have an undeveloped respiratory system, which means they may experience different respiratory problems, like having difficulties breathing on their own. Some of the factors that contribute to these respiratory problems in neonates are, firstly, prematurity. So this is when a baby is born before 37 weeks of pregnancy. Premature babies have immature lungs that are not fully developed and may not produce enough surfactant. And surfactant is a substance that helps to keep the alveoli in the lungs open and prevent them from collapsing. Another factor contributing to these respiratory problems in neonates is surfactant deficiency. This is when the lungs do not produce enough surfactant, or the surfactant that is being produced is not effective. Surfactant deficiency can cause respiratory distress syndrome, a condition where the lungs are stiff and cannot expand properly, leading to low oxygen levels in the blood. Lastly, another factor that contributes to these respiratory problems is congenital defects. So these are abnormalities that are present at birth, such as congenital heart disease. These defects can affect the functionality of the lungs or the heart, causing impaired gas exchange and oxygen delivery to the tissues. So oxygen therapy is essential for neonates with underdeveloped respiratory system because it improves their oxygenation and prevents further complications. Therefore, careful monitoring and adjustments are necessary during oxygen therapy because providing too much or too little oxygen has negative effects on the neonates. Providing inadequate oxygen leads to low oxygen levels in the blood, whereas providing too much oxygen leads to a high saturation of oxygen in the blood, leading to oxygen toxicity, which can damage the cells and tissues of the neonates. In summary, neonates face unique health challenges due to their developmental stage. So proper medical care, monitoring, and supportive interventions are crucial during this critical period of life. Moving on, let's look at the challenges of neonatal care. The first challenge is inadequate physical resources. So many hospitals do not have enough infrastructure and medical equipment such as oxygen concentrators and ventilators to provide adequate care for newborns. And another challenge is shortage of healthcare workers. So there is also a shortage of healthcare workers, especially nurses, who can deliver quality neonatal care, including oxygen therapy. Another challenge is inadequate specialist neonatal training. So this means that the health workers may not have the necessary knowledge and skills in order to provide quality neonatal care. There are also gaps in communication and documentation, whereby there is poor communication within clinical teams, and also most clinicians do not have reliable records, registers or reports of neonatal activities and outcomes, and this affects the quality of neonatal care. Reaching this far, I'll leave the floor to my colleague Aubrey to continue with the presentation. Over to you, Aubrey.
Thank you very much, Jane, for taking up that part of the presentation. I'll take you through the various oxygen equipment that are found in neonatal care units. We're going to look at the oxygen concentrator, the oxygen flow splitters, the pulse oximeter, and we're also going to look at the BCPAP machine. I'll take you through the first types of equipment, the first three types of equipment, and the fourth one will be taken up by Vitumbiko Msowoya from Nest 360. So let's dive in. The oxygen concentrator is a medical device that produces oxygen of about 90 to 95.6% from the surrounding air using a technique known as pressure swing absorption. And oxygen concentrators come in varying capacities. Others have cumulative flow rates of 5, 8, others 10, and they can even go up to 20 liters per minute. Some may have one oxygen outlet port, others may have two. It just depends on the various models. It is important to always take note that not all concentrators at 2 flow meters are dual flow oxygen concentrators. And this is to say that some concentrators that have 2 flow meters might not depict that those concentrators will produce oxygen from all those 2 outlets. Others have one outlet for oxygen and the other one for air. And usually they're labeled on the flow meters. So you just have to double check. If that concentrator has 2 outlet ports for oxygen, then you can use it. If the other outlet port is for air, then make sure that you also using it for the right reasons. So now we're going to look at how the oxygen concentrator works. So the oxygen concentrator has a compressor that sucks in ambient air from the surrounding. The air is then compressed and it is directed to the solenoid valves or the rotary valve, depending on the model of concentrator that you're dealing with. And then the valves are the ones that direct air into one of the sieve beds, and the sieve beds contain a molecular sieve known as zeolite that filters out the oxygen, the nitrogen, and allow oxygen to pass through. The oxygen is then directed into the product tank that's usually fitted with a pressure regulator to control the amount of pressure of the oxygen that is directed to the flow meter, and then it is directed to the patient. So the nitrogen that was filtered out by the zeolite is then vented out through the exhaust muffler during the depressurization process. So as you can see, that's just a pneumatic schematic diagram of an oxygen concentrator. The Oxygen Alliance has a lot of resources concerning oxygen concentrators. So this was just a brief explanation. There are a lot of resources on the website, the Oxygen Alliance website, and the YouTube channel as well. So you can go visit the website to get more insight on how various oxygen concentrators work. But basically, it just produces oxygen. It's an oxygen source. So that's about the oxygen concentrator. We're going to move on to the next type of equipment, which is the oxygen flow splitter. So the oxygen flow splitter is an accessory device that divides oxygen from one source to several patients at independent adjustable flow rates. So this is very important because if you have a neonatal unit with, let's just say, 5 patients and you only have one source of oxygen, you can be able to use the flow splitter to independently deliver oxygen to these patients that are in the neonatal unit. So as I mentioned, it's an accessory device. You cannot operate it on its own. You have to use it in conjunction with another equipment. So you can use an oxygen source, such as an oxygen concentrator. You can use an oxygen cylinder, or you can even use piped oxygen from a plant. You can also use the flow splitters with a CPAP machine, providing that the oxygen source and the splitter have the capacity for the flow rates that are required. So the oxygen concentration that is delivered by the flow splitter remains unchanged from that of the oxygen source. So you always have to make sure that the oxygen source is providing the recommended amount of oxygen concentration, because if it's low, then the splitter will not change that. That low oxygen period will also be delivered to the patient. So it's always advised to double check the period of the oxygen that's coming out from the oxygen source. And it is also recommended that the source of oxygen, might be the concentrator or the oxygen cylinder, must be adjusted to provide a flow at least 1 liters per minute oxygen more than the total requirement from all the ports that are in use. So let's just take a look at the picture that is in the slide. You have a splitter that has 5 flow meters. So let's just assume 3 flow meters are closed and 1 is open, and all these 2 open flow meters are open to a maximum of 1 liter per minute. So that means the total of the required flow would be 2 liters per minute. So we are just adding the 2. So the setting on the oxygen concentrator needs to be 3 liters per minute, because they're saying that it should always be at least 1 liter per minute more. So that is to ensure that if there are any discrepancies in the flow, that 1 liter per minute that you've set will give you that cushion and ensure that the required flow is still delivered to the patient. Moving on, let's look at how the oxygen flow splitter works. So when you open it up, it simply just has an internal tubing with individual flow meters that are split from the incoming flow of oxygen source. And the flow splitters can provide flow rates from 0.1 to 2 liters per minute each port. So it is always recommended to check that the flow splitter is able to provide independent flows. So you do not want to have a situation where if you adjust 1 flow meter and that flow meter is also affecting the other one. You want to adjust the flow meters independently, and 1 flow meter should not really affect the other. So generally, that's how the oxygen flow splitter works. We're going to move on to the other oxygen-related equipment, which is the pulse oximeter. And the pulse oximeter is a device that is used to measure the pulse rate and the oxygen saturation of the patient. It can be used to determine the severity of an infant's illness by evaluating if blood oxygen saturation is low, and if the blood oxygen saturation is low, you can make a decision on whether to provide oxygen therapy for the patient or not. So they come in different types. Others are handheld, others are fixed or tabletop. And for the tabletop, they're mainly used for continuous reading at one patient. While for the handheld, you can be able to sort of like conduct spot reading for individual patients. So for the pulse oximeter, for adults, it is usually placed on the index finger, while for the neonates, it is usually attached on the right hand or on the foot. And also, if the blood oxygen saturation is reading less than 90%, or about 15 minutes after birth, the patient should be considered for supplemental oxygen therapy. Let's now look at how the pulse oximeter works. Before we get to how the pulse oximeter works, let's just briefly look at how oxygen is carried in the bloodstream. So oxygen is carried in the blood by binding to hemoglobin in red blood cells. Each hemoglobin can carry up to 4 oxygen molecules, and at that point it becomes saturated. The color of the blood depends on how much hemoglobin it is saturated with. So if there's a lot of oxygen in the hemoglobin, it will be bright red, and if there's less oxygen, it becomes dark red. So pulse oximeters basically differentiate between the light absorbing properties of oxyhemoglobin and deoxyhemoglobin at 2 different wavelengths in the red spectrum. And it uses this difference and changes in the local blood volume to calculate the saturation of oxygen in the blood. So as you can see on the diagram, we have various components of the pulse oximeter. Let's focus on the probe that has an LED and the receiver. So the LEDs, the pulse oximeter usually has 2 LEDs, an infrared LED and a red LED, and these emit light, and that light is passed through either the finger or the foot in the neonat's case, and then the receiver will receive the light that passes through. So according to how much oxygen is in the blood, the receiver will do the calculations to give you how much oxygen saturation is there in the blood. So that's basically how the pulse oximeter works. It should be noted that if neonates should reach the blood saturation, oxygen blood saturation of 90 to 95% by 15 minutes after birth. If this does not happen, then you have to make a decision on either to provide oxygen therapy using an oxygen concentrator or other sources of oxygen. So basically, that's how the pulse oximeter works. Right now, I'll hand over the floor to Chimwemwe Tiyesi to take you through the care and maintenance of the oxygen-related equipment for neonates. Thank you very much. Over to you, Chimwemwe.
Thank you so much, Aubrey, for that part of the presentation. Now I'll take you through the care and maintenance of oxygen-related equipment used in neonatal wards. Specifically, this will be oxygen flow spreaders, pulse oximeters, and also oxygen concentrators. So we'll start with the oxygen flow spreaders. As my colleague Aubrey already explained, oxygen flow spreaders help to channel life-giving gas to multiple infants or patients at the same time. However, despite this crucial role, these devices can fail. That is why it is very important to do regular checks and adjustments so that we provide reliable oxygen to the patients. Some of the common problems with flow spreaders include stuck flow meter bore, kinking and blockages, and also leakages. So moving on, we are going to look at the stuck flow meter bore and how you can avoid that problem in oxygen flow spreaders. So this often results from condensation build up inside the flow meter pipe and cause the bore to get stuck most often at the top. So this one is mostly because of improper connection of a humidifier bottle. So if a humidifier bottle is connected in between the oxygen source and the oxygen flow spreader, you will get this problem definitely. So this blocks oxygen supply to the patients, of course, and may lead to complications. So the solution is to connect the humidifier bottle before, or not before, but after the oxygen flow spreader. Next, I'm going to show you a picture on how you can do this correctly. So as you can see in the graphics, we have this larger diameter pipe coming from the bottom here. This is going to the inlet of the flow spreader. After the flow spreader, we have these tubes where there is a connection of a bacterial filter going into the humidifier bottle. So this is the correct way. You should avoid at all costs connecting the humidifier bottle just after the oxygen source and in between the oxygen flow spreader. Moving on, we are going to look at the second problem, which is kinking and blockages. Mostly is caused because of bending, pinching, and placing heavy equipment, dirty, dust, or moisture accumulating inside the pipes. So to avoid this pinching and bending, what you need to do actually is first, whenever you want to supply or when there is oxygen supply, you need to check if the oxygen flow rate is what you set it at. Mostly if there is a blockage, you get low oxygen flow rates at the end. You should also make sure that the pipes are not very long so that there is a possibility of placing other equipment on top of them. If they are long, you can coil them up and put them very close to the oxygen source or very close to the oxygen flow spreader so that we don't unnecessarily have pinching and bending around it. So, of course, bending and blockages will have adverse effects on the oxygen delivery, such as reduction in oxygen flow, inaccurate flow readings on the flow meter, system malfunctions. The system can malfunction if you have a blockage. And if you do this, you are definitely closing the outlet of the oxygen concentrator if you're using an oxygen concentrator as your oxygen source, and this may lead to alarms going off and cause other problems in the system. And lastly, the other effect is patient discomfort. Moving on, we are going to look at the last common problem, which are leakages. So mostly leakages are caused due to clogged or worn out hoses. This is often due to edging of the pipes where they can just clog or break anyhow, so which may cause leakages in the system. Loose connections also are a possibility where you are connecting the pipes at the inlet, where you are connecting the oxygen source to the flow spreader, or where you're connecting the pipes, the tubes inside the oxygen flow spreader to the flow meters of the oxygen flow spreader. Of course, unlikely, very unlikely, manufacturing defects can exist, which may cause other problems like the leakages in the system as well. So this will also reduce oxygen delivery to the patient. It will also lead to inaccurate flow readings on the flow meter, wastage of oxygen, safety concerns. Another thing I should mention here on the causes of the leakages is the damaged oiling. You can see in the graphics here where you have the knob, where the knob is placed actually, and you do the connection, there is a gasket. So this gasket sometimes can be damaged and can lead also to leakages. Moving on, we are going to look at care, cleaning, and also maintenance of oxygen concentrators. So before you start any cleaning work, you need to make sure that all electrical medical equipment are disconnected from the power supply. That is the medical equipment you want to do the cleaning or the preventive maintenance on. Also make sure that activities are performed away from the medical wards, preferably inside biomedical workshops. Another thing is also the clothes you wear when preparing disinfectant or when you are cleaning the oxygen concentrators or any other medical equipment. So you need to have a face mask covering the nose and the mouth. You should also have covering shoes, working covering shoes, and you also need a long-sleeved liquid resistant gown or an apron so that you protect yourself from infections. Next, we are going to look at why it is important to put on shoe covers when entering your neonatal ward for assessment of oxygen concentrators or any other medical equipment in the neonatal ward, or when you want to take oxygen-related equipment or any other equipment to the maintenance workshop. So you need to have or to put on shoe covering booties, the one you see in the pictures. Some look slightly different, some look exactly like in the picture. So as engineers, we are always part of the solution and we should not be part of the problem. So we need to wear these booties to avoid spread of infections in the neonatal ward. Next. So the World Health Organization recommends that the oxygen concentrator humidifier must be washed, rinsed, and disinfected daily when used on the same patient and disposed thereafter. So the World Health Organization regards this humidifier board as the use once type of medical oxygen accessory. If you're using it on the same patient, of course, you can use it multiple times. But if you want to use it on a different patient, you need to discard it and throw it away in a designated bins or waste management bins, that is. So the World Health Organization, of course, the way they recommend is to empty the water bottle from the humidifier, rinse the humidifier flask under running water, fill in with properly distilled water, or you can put in cold water that has been previously boiled. So you should also make sure that you don't exceed the minimum and minimum scale lines on the humidifier bottle. You're going to see it later. So they also advise that you should not use tap water, even if it is safe drinkable water, as it may still contain germs. But this often is not the case with low and middle income countries where resources are not available, which leads to healthcare providers to reuse the same non-heated water humidifier bottle. So what they do is to clean it mostly with mild detergent. So it is discouraged to use heavy detergents on this bottle. So some opt to use mild detergents like dishwashing soap. And it is also forbidden or discouraged to use any form of alcohol-based disinfectant to clean the humidifier bottle. So moving on, we are still going to look at the same humidifier bottle on how you can how you can check for leakages. So what you can do is to do visual inspection. You can also use a paper towel test, a tube test, and also a sound test. So for visual inspection, you can start by thoroughly examining the bottle for any visible cracks, punctures, or damages around the seams, the base, and also all the connecting points. So if you see anything between the bottle itself at the bottom and the top cover, if you can see any punctures or cracks, it's high time you fix those cracks or leaks. Or if it's not fixable, you can change the humidifier bottle altogether. The other test is to put a towel test between the top cover of the humidifier bottle and the bottom parts. Put a paper towel, turn on the oxygen concentrator, let it run for some time, and observe it if there's any dampness around the paper towel. You can use a white A4 paper, that is, or any other paper that can fit around the humidifier bottle. So if you see any dampness, it means there's a leakage or the bottle is not tightly sewed together. So what you need to do is to fix the problem, or if it's not fixable, again, you need to replace the humidifier bottle. You can also do a tube test. You let the oxygen concentrator run. This is best done if there is a connecting tube between the flow meter to the oxygen source. So what you do is to turn on the oxygen concentrator, tilt it, and see if there are any leakages. If you get leakages, it's high time you replace or fix the humidifier bottle. You can also do sound tests. So what you can do is to listen for unusual sounds like hissing, bleeping, or gargling, which may also indicate that there is a leakage somewhere. Another test you can do, of course, is to block the oxygen outlet from the humidifier bottle where it's lit an oxygen outlet. If you block it, wait and listen if you can hear the pressure relief valve popping. If you hear it popping, you know that, of course, the bottle is intact and there's no problem. But if it's not, the pressure relief valve is not popping, it may mean there's a leakage somewhere and you need to fix. Also, as I said, there are always maximum water level and minimum water level lines. You need to observe them. Inside the humidifier bottle, there's a diffuser that often, if it's not cleaned, it gets occluded with dirty and other elements inside. So you can also notice if for any other reason you are hearing the pressure relief valve popping, it may mean that the diffuser is occluded and you need to wash it. Some people use a little bit of vinegar to clean the humidifier bottle and that part of the diffuser as well. Next, we are going to look at how you can use or how you can handle brand new or unfamiliar oxygen concentrators in the nursery or neonatal ward. So introducing a new oxygen concentrator to a nursery ward require careful preparation and also familiarization. So you should not assume familiarization. So even experienced healthcare workers may get this wrong. They may assume they know how to operate the oxygen concentrator or any other medical equipment for that matter, just because they know one brand or other brands. But this one, if it's new, there's potential differences in the controls and also alarms, which may actually be very important and may lead to dire consequences if they are not taken correctly. So you can also do visual inspection of the unit. Of course, you need to read the manual and pay close attention to the specific model setup, operation, and also maintenance procedures. Next, we are continuing with the brand new and also unfamiliar oxygen concentrators. So for power up test, what you need to do is to check the voltage rating on the oxygen concentrator. Some oxygen concentrators are rated for 230 to 240 volts, while others are rated for 110 volts. So if you're in an area where you have these differences, you need to take care because you cannot just plug them anyhow in a different rated voltage power supply. So another thing is, if you have 110 volts oxygen concentrator and you are in a country where you have 230 to 240 volts power supply, you need to have a step-down transformer. However, you should take note that the step-down transformer will still work at the same frequency as your power supply, not as the 110 volts requires like 60 hertz. So this may actually lead to performance issues. You may actually get low oxygen purity comparable from if you compared it, if you had like the 110 volts and at 60 hertz, the one it was designed to work at. So pay close attention to that. Also verify that power is connected correctly and also operates smoothly. Listen for noises and smells. Also, you can measure the oxygen flow rate and purity at various settings. You can also do a block test at the outlet of the oxygen concentrator just to see if the flow meter ball goes down. If it doesn't completely go down, it may actually tells you that there is a leak somewhere. You can also test by simulating like the low oxygen flow and also power outages. Next, we are going to look at how you can clean and inspect air intake filters. So for gross particle filters, what you can do is to take them out. If they have dust on them, you blow them with a blower and soak them in cool soapy water, then put them in a dry shaded area to dry them up. You can put them back when you're done, or you can store them if you had it like just a spare filter. When you want to clean the whole oxygen concentrator, you need to use a damp cloth or disposable wipe soaked in a detergent. The detergent can be a mild detergent, of course, not the heavy detergents like washing soaps. And also, if you want to use detergents like disinfectants like chlorine, what you need to do is to pay close attention and know what the manufacturer recommends. So you need to wipe off any remaining residue with a dry, lint-free cloth, and also avoid excessive liquids when cleaning the oxygen concentrators. Next, we are going to look at how you can inspect the and do the maintenance of bacteria filters. So you should not wash the bacteria filter, and the change should only be done by maintenance department. So if you want to use an oxygen concentrator on another patient, make sure you disconnect, clean and disinfect it before you move it on to another patient. Also dispose of any single-use patient interfaces if that's applicable in your setup. And ideally, you should dispose in a designated infectious material or biohazard or waste containers. Next, we are going to look at how you can take care of pulse oximeters. The first thing you need to do is to perform risk assessment prior to entry of the room. The same measures you should take about donning yourself when entering the neonatal or nursery ward. So you should also consider patient care tasks and additional risk during the disconnection of the device. Turn off the device and disconnect from the patient. Ensure batteries are taken out when clinical and safe if the pulse oximeter is using batteries. Wipe off and clean with the detergent, the same detergent I talked about, or alcohol-based disinfectants. Wipe out the outer surfaces, sensors, and cables from top to bottom, and also use a cloth or disposable wipe soaked in a detergent, that is. Then you can use the same lint-free dry cloth to just clean everything up. You should also avoid the use of excessive liquids, as I already said, because they may damage the insides, the electrical parts of the pulse oximeters. You can use mechanical force in modulation, that is because these are very small and also sometimes brittle medical equipment, so you need to use mechanical force in modulation. So reaching this far, I'll hand over to my to an engineer from Nest 360, our guest, Vitumbiko Msowoya, who has vast experience in neonatal oxygen-related equipment, their care and maintenance. So over to you, Vitu.
Wow, what a wonderful presentation. Thank you so much for inviting me to this forum. I'll take you through bubble CPAP presentation. We all know what a bubble CPAP. I believe some of us have an idea, but let me just quickly go into the presentation. By the end of this presentation, we expect to have covered these indicative contents. We need to know what clinical applications of a bubble CPAP and how it works, the components that are inside and outside the bubble CPAP, preventive measures, and as well as troubleshooting and remedies. So what is a bubble CPAP in clinical application? So this machine, normally, it is there to address conditions of RDS. So we know when neonates are born, especially preterm babies, they're not able to produce enough surfactant due to underdeveloped lungs. So with that, it results into deficiency in surfactant, which leads into collapsing of the lungs alveoli at the end of each expiratory stage. So a bubble CPAP delivers a continuous positive pressure. So here the keyword is positive pressure into the infant airway to maintain the residual volume during expiration. How it works? Very simple. So it delivers a regulated, controlled, and safe pressurized air to keep the alveoli open during expiration. The keyword is expiration. So the pressurized air prevents the alveoli from collapsing, from sticking, by retaining a residual volume of air during exhalation. The bubble CPAP only draws the ambient air and blends it with oxygen. So there are two things, air and oxygen, to create a blended total flow, which is normally termed as fraction of inspired oxygen. So we all know that at room temperature for every human is 21%. So the blended flow is then routed through the inspiratory tubing into the baby's airway. So we use tubings to deliver this precise pressurized air. So we might be wondering how pressure is generated. So pressure is generated by submerging the distal end of expiratory tubing into the water bottle. The water bottle is the pressure bottle. So the depth of water determines the pressure in the airways. So if the height is, if we increase the height of the level of water, it means we're increasing pressure in the system. So bubbles are generated because air is passing through the water. So that creates pressure oscillations in the airway, which facilitate gas exchange. So pressure is generated from bubble CPAP is not constant, it varies, but rather resonates over certain means and at different instances. A bubble CPAP is basically consisting of an air pump. It's an electric air pump and pressure regulator. Two aspects there, the air pump and pressure regulator, which is the bottle. So the air pump draws in air through a filter. We'll appreciate in the next slides on how this air pump is. So this reduces FiO2 to safe levels. The pressure regulator is achieved, the pressure regulation is normally achieved by using a column of water. So a column of water can vary depending on the condition, clinical judgment, that is. So the distal end of a nozzle prong is dipped into the column of water to complete a circuit and generate pressure. So this therapeutic FiO2 can be regulated by manipulating the flow rates. So we have two flow rates, flow meters. We have oxygen flow meter and total flow meter to achieve these blending ratios. So let's run into the external components. Let's appreciate this diagram. I'll start with the left side. There's a power switch, which is normally used to power on and off the machine. We have the patient port, which is normally a port connected. It's the outlet port for connecting the inhalation tubing, which goes to the baby. And here we have the O2 port, which is the port where we outsource oxygen from the external sources. It might be an oxygen concentrator, or it might be a piped oxygen from the wall. So we also have an oxygen flow meter here, and we also have a total flow meter. And here we have this bottle, the pressure regulator bottle. So we'll appreciate in the next slide on the pressure regulating bottle. Then we also have the patient inspiratory tubing, which is this one. So we have two tubings. We have inspiratory tubing, and down here we have the patient expiratory tubing. And then we have the hat, which is to serve a purpose of warmth, to keep the baby warm. So we normally put it, dress the baby at the head of the baby. So we have the hat clips to secure this hat. In the nozzle plungs. So the nozzle plungs, they might vary with the sizes of the nostrils. So let me quickly explain about these features. So the oxygen flow meter will be there to regulate the oxygen flow from the outsourced oxygen. The total flow meter will regulate the flow rate of the blended oxygen. So this one will regulate the oxygen which is coming to the CPAP and the air which is being generated by the CPAP itself. This bottle is there to regulate the pressure within the system. We have the heart clips to secure, I've already explained, and the expiratory tubings and inspiratory tubings. Let me just spend a few moments on inspiratory and expiratory. There are different structural differences, how you can differentiate them visually as well as characteristics. So we can start with inspiratory tubing. So these inspiratory tubings, normally they are smaller in diameter than the expiratory tubings, and the expiratory tubings are longer than the inspiratory tubings. So here we have these three pictures. We have the first picture showing this one of our health worker placing the pressure bottle, and we have this the second one whereby we have this patient, personnel is connecting the tubings to the patient port. And lastly, we have the pressure regulating bottle showing the graduated readings. So it starts from 1 to 10 centimeters. So the safe range is the green zone. So the water level has to be within this green zone for safety therapeutic pressures. So let's look at the internal components. On the internal components, we have, after we have opened the CPAP machine on area view, you're able to see, I'll start with the left side. So we have the power entry module. Then we have the power supply unit in this cabin. Then we have the alarm module here on the same. Then we have the patient port exposed from outside and the on and off switch, oxygen port, total flow meter, oxygen flow meter, pressure regulator, and the pump, the air pump, and spare part key. So let me start with the pump. So this pump is an AC pump. It runs on 220 VAC. Normally it ranges from 100 to 220 VAC. So with Malawian power grid, this one is suitable. So this pump is an inductive AC pump, which has two coils in opposite. They have two opposite, has two opposite coils with different polarities, connected by a central magnetic rod, that when other coil is energized, the other one is de-energized. So at the end of this magnetic rod, between these two coils, we have two diaphragms. The black side, the other side is black, the other side is black. So they have two diaphragms. When the other coil is de-energized, the other one is energized. So with that, we all appreciate in engineering that when a coil has been energized, it means it temporarily has an electromagnetic effect. So with that, that diaphragm will be reciprocating, pumping air outside the system. The power supply unit is normally powered with 220 volts according to Malawi. So 220 volts input and output is 12 volts. That 12 volts is DC 12 volts, which is mainly used to, which is supplied to the alarm module. So the alarm module is down, is also cooperated together in this power supply unit, which is there to accelerate alarms whenever there's a power failure. So this one is a power failure alarm module, which is fed with 12 volts DC from this power supply unit. So when there's a power failure while the machine is on, the board will sense that there's no current coming and it will buzz, alerting the user that there's a problem. So that's very important. So the next slide is showing us how we can access the air filter, which is just down the air pump. So this air pump, we normally access the air filter down, as the picture shows. So let's go to the preventive maintenance. So in preventive maintenance, we have two types of preventive maintenance. We have user level maintenance and we have the technical level maintenance. So on after use, normally the users, which is the user level maintenance, the user has to turn off the machine, unplug, disinfect or control tubings and power button. Weekly, turn on the CPAP machine to a total flow of 10 liters per minute, connect to an oxygen source, 2 liters, and run it for 15 minutes. So this can be done by the user or the technician. So monthly, this one is for technical, test total flow capacity, bubbling effect, functionality, and power failure alarms. Quarterly, also responsibility for the technician, measure grounding integrity, earth casing leakage current, visual, and all other components for damage. So annually, it's responsible for the technician or the biomed to forecast for spare parts. We know some spare parts. We know that after assessing that these spare parts, we need them most than the others. So focus for those, and as well as accessories. So let's run into troubleshooting and repair. So on troubleshooting and repair, we expect to have problems whenever we're using a CPAP machine. So on Pullman CPAP machine, we have, okay, yeah, good. So we have the first symptoms, maybe the machine is not turning on. So what are the remedies? So we go to the power cable. We check if the power cable is not faulty. So the power cable, we check the fuses and on off pattern, maybe it's blown out because of power fluctuations and for the internal wiring. So maybe you can check for continuity and resistance of the wires. The machine is able to turn on, but does not reach to maximum flow rate. So what can be the problem? So you check the flow meter, check for leaks, damages. If there's a need for replacement, you replace dislodged and kinked internal tubings. Clogged air filter might be one of the reasons, so you replace the filters. Weak air pump, replace the pump. Yeah, so we have another symptom. Normally, we can have a situation whereby the machine is turning on, but no air flow at the patient port. This is very common. So we can have a problem. Normally, patient outlet port is obstructed with foreign substances. Looking for visible sign can be one of the first line remedies. So internal tubings might be obstructed, dislodged. Check total flow 40, or the total flow meter might be also 40. So because of over adjustment of the control knob sometimes. Yeah, so the symptom might be the machine is able to turn on O2 and total flow bobbin not rising. So both flow meters, the bobbin are not rising. What can be the problem? So we check for the dislodgement or maybe the obstruct internal tubings. Sometimes we might have overstaying CPAPs whereby some flies can build some nest inside or some debris. They can block the tubings. So internal leakage might also be the cause. So but the bobbin might be stuck due to condensation, as my friend also lightly put it. So the remedy is to disassemble and clean the flow meter. Reaching this far, I think I've come to the end of the presentation. If there are questions, please feel free. I'll be very happy to assist in addressing them.
Thank you very much, our engineers and our guest, Vitumbiko, for that detailed presentation. So the floor is now open to questions or comments. So since you're running out of time, we'll take a few questions. So we had a hand from Amity and we have another question in the chat. So I'll read out the question in the chat, then Amity can ask either a question or a comment. So the question in the chat says, why is the world not coming up with metallic humidifier bottles? That I think could be the easy way to infect and for long use. Is there any specific reason why plastic is preferred over metal? So that is a question from Toby. We also had a hand from Amity. So Amity, if you're still around, please ask your question or you can say your comment. Please, you're free to come off mute before we answer those questions. We also have another question in the chat from Engineer Merisente, which says, just wondering if there are any IPC measures to be taken while performing maintenance on CPAP. So we also have a hand from Lamik Chimango and good luck. So we'll start with Chimango, then good luck will follow with the question, then our engineers will answer the question. Over to you, Lamik.
Right, thank you so much. It's a powerful presentation. Thank you for the detailed information that you've given. I just have a single question. where you talked about the splitter and the humidifier bottles connected after the splitter. So I saw that there are also bacteria filters connected to each of the bottles. I'm just trying to figure out what is the whole essence of having each. I mean, so many filters. I mean, bacteria filters connected from one machine, which is also having bacteria filter. So I'm just interested in the cost of the overall system which is made. Thank you.
Thank you very much, Chimango. Good luck. You can come off mute and ask your question or say your comment.
Okay, so for the bubble zipper, if the pressure on the bottle is less than 5, will it generate the much needed pressure? That's one. Then for the maintenance of the humidifier, can one use the humidifier for more than one patient?
Thank you very much. Okay, so our engineers and our guests, please go ahead and take these questions.
All right, thank you so much, Sharon. I'll take that question from Tobias Bendabinda. He was asking if we can, why don't they use metallic humidifier bottles instead? So while the metallic humidifier bottles may seem like a good option for humidifier bottles, at first glance, due to its maybe ease of disinfection and durability, there are several scientific and practical reasons why plastic is currently preferred materials. So there are safety and health concerns, and also there is another thing that is cost. Maybe before you go all the way there, another thing would be you would want to have a clear and a transparent humidifier bottle, which in this case a metallic one may not work. So for the health and safety concerns, some metals do leach. There is metal leaching, what they say. So certain metals can leach into the water, and especially with repeated cleaning and disinfections, these leached metals, even a small amount, could pose health risk if inhaled through the humidifier mist to the patient. So that's actually a health concern. And also there's corrosion issue, where some metals actually corrode in damp environment. So if you want to go for metals that don't corrode, actually you may now worry about the cost. So the other thing is the cost, as I already said now, as I have just said now. So I think that answers your question, Toby. Over to you, Sharon.
Thank you very much, Chimwemwe. Maybe Vitumbiko, you can take the questions for the bubble zipper, please.
Yeah, let me repeat the question. I think I heard you saying that if the water level is below 5, yeah? Is it right?
Good luck.
It's below the green range, yes.
It's outside the green range.
Yes.
Okay,
Below
so the answer, yeah. So from 5 to 8 is the safest range of achieving the therapeutic pressure and for you to achieve the bubbles. So below 5, it means we are reducing pressure below the therapeutic levels. And above 8, it means we are increasing therapeutic pressure from the normal range. And there are clinical conditions at which this can be achieved, can be subjected to. So we only advise people not to go outside those ranges unless if maybe there are clinical conditions that might pose to be right for the range to go up above 8, maybe 9 or somewhere. But I've never had experience of having a situation whereby the premature baby has been subjected to less than 5 or above 8. Because otherwise it might cause either barotrauma to the baby's lungs, or it might not achieve the required
Okay, for adults, you can go beyond 8.
Yeah, for some it can go above 8, but based on clinical
I mean for adults.
judgment.
I mean for adults.
Yeah, for adults, yeah. For adults it can go above 8, yes. But since
Okay, what about the okay.
Yeah, since we are range is 5 to 8.
Okay. What about the humidifier?
The humidifier, we don't have the humidifier bottle in.
No, I mean for oxygen concentrator.
Just to complement on what my fellow friend talked about, I believe that plastic is a good option because it can be it is easy to produce, and for the use in terms of clinical use, you are able to monitor the water levels, unlike a metal, unless if you put a water level glass, so which is costly anyway for you to implement a water glass on a metal. So with African setup, I think it will be expensive. It can be expensive to venture into metal humidifier bottles, and also it might also maybe increase condensation. Looking at the properties of a metal, that maybe water will just be condensing and will not have the effectiveness of using water in a regulator or humidifier bottle. Thank you.
All right, thank you.
Thank you very much, Vitumbiko, for the answers, and thank you very much, our engineers. So since we have run out of time, we won't be able to take more questions, but we have taken note of the questions in the chat, and the ones that were asked we will reply them to your emails. So reaching this far, this is the end of today's talk. We thank you very much for joining. So if you have any questions for us, please email us at info@oxygenalliance.org. And if you haven't shared with us your email addresses, please do so in the chat. So until next time, it's goodbye from us.